on making ionic bonds, ionic compounds using Lewis dot structures. So whenever we talk about ionic bonds, remember they are formed by the transfer of electrons from metals to non-metals. Let's take examples to understand. We can start with this example of sodium and oxygen. So how do we know what is the valence electron? For representative elements, for A group elements, group 1, group 2, and then 3 through 7, valence electrons are equal to the group number. So sodium has a valence electron of 1 and oxygen has valence electrons of 6. In order to obtain an octet, so why do elements lose, gain, or share electrons? To complete their octet, to be like their nearest noble gas. So sodium is ready to lose one electron. However, one atom of oxygen needs 2 electrons in order to be stable to complete the octet. So we are going to draw one more atom of sodium. Here, this is another valence electron. So this is going to be lost here, and this valence electron will be given to this oxygen as well. So sodium has now lost 1 electron and oxygen has gained 2 electrons. So as a result, what happened? This sodium ion and this oxide ion, they both became like their nearest noble gas, which is neon. And in order to here Na plus and O2 minus, whenever you have unequal charges, you do the crisscross and you're going to get Na2O. You don't write any charges in the final formula because compounds are electrically neutral. So this is going to be the ratio of 2:1, 2 atoms of sodium, 1 atom of oxygen needed in order to make a compound called sodium oxide. Okay. If we have to make sodium oxide, we need 2 sodium atoms and 1 oxygen. So formula for sodium oxide is Na2O. This was the Lewis dot structure for sodium oxide using sodium and oxygen. Let's make another compound using aluminum and chlorine. Aluminum is 3 valence electrons, right? So it's ready to lose 3 electrons, and chlorine, however, needs only 1 more electron. That means we will need 3 chlorine atoms so that all those 3 electrons from aluminum can be given away, and this way aluminum and chlorine, they all become stable. So one aluminum lost 3 electrons, that is why 3 plus, and 1 chlorine gained 1 electron. So this is whenever the opposite charges are unequal, you crisscross, you are going to get AlCl3. Now here, this Al3 plus ion, aluminum ion and chloride ion, aluminum becomes like its nearest noble gas, neon, and chlorine becomes like its nearest noble gas, argon. After all, they lose, gain or share to be like their nearest noble gas. Okay guys, now what is the ratio of atoms? If you look at the ratio is 1:3. 1 part of aluminum and 3 parts of chlorine. So if we have to make aluminum chloride, name of this compound is aluminum chloride, not aluminum chlorine, aluminum chloride. Binary ionic compounds, they end in IDE. So aluminum chloride, if we have to make, we need 1 atom of chlorine and 1 atom of aluminum and 3 atoms of chlorine. That is why the ratio is 1:3. Let's make another compound, calcium and sulfur. So calcium, 2 valence electrons and sulfur is 6. That means it is ready to lose 2 and this one is ready to gain 6. This I should not right now because it is only 6, sorry. So don't look at these. 1, 2, 3, 4, 5 and 6. Okay, now let's say these electrons came here. like this. So initially sulfur had 1, 2, 3, 4, 5, 6. Now it has 8 because it is gaining 2 electrons from calcium. So 2A, Ca2 plus, and sulfur is gaining 2, so it is 2 minus. Whenever the charges are equal, you simply cancel them. Okay, and when you cancel them here, you are going to get CaS. The Ca2 plus ion is actually having electron configuration of argon, and so is the sulfur. This one also has the electron configuration of argon. So calcium ion and sulfide ion. So the name of the compound is calcium sulfide. And the ratio of atoms is 1:1. Okay, all right. Let's do another example. Just one more. Magnesium and phosphorus. So magnesium belongs to group 2A, so 2 valence electrons, and phosphorus belongs to group 15 or 5A. So 1, 2, 3, 4, 5. Only 5 valence electrons. Alright, that means it needs 3 more electrons in order to complete an octet. However, one magnesium can lose only 2, so we have to figure out the ratio. So if we have one more, 1, 2, 3, 4, 5, alright, so that means we are going to need another magnesium. Okay, so this is going to give 1, 2, and 3. Alright, now this is going to give it 1. Now that means we need another magnesium. There you go. Alright, so for 2 phosphorus, how many magnesium we need? We need 3 magnesium, and one magnesium is losing 2 electrons and one phosphorus is gaining 3 electrons. When charges are unequal, you crisscross. You are going to get Mg3p2. So what is the ratio? 3 parts of magnesium and 2 parts of phosphorus, meaning 3 oxygen atoms and 2 phosphorus atoms when you have to make a compound magnesium phosphide. Sorry, 3 parts of magnesium and 2 parts of phosphorus. Magnesium phosphide. Okay guys, and which one are the nearest noble gas? Which noble gas did they become? Magnesium ion, this one, is having the same electron configuration as neon, and phosphide ion is having the same electron configuration as argon. Okay, all right, just it ends in IDE, remember that. So let's try you guys. Okay, so I wanted you to try on your own. So you try this, okay, and check your answers if this is what you got or not. So what's happening here? Potassium is losing 1 electron, bromine is gaining 1. So it's losing 1, gaining 1. Alright. Magnesium is losing 2 electrons. That's why we need 2 iodine if we have to make a compound with magnesium and iodine, because each iodine is going to gain 1 electron. So magnesium losing 2 and iodine gaining 1. Here, if you're making compound using potassium and oxygen, since one oxygen needs 2 electrons and one potassium can give away only 1, that is why we need 2 potassium atoms. When this potassium lost 1 electron, it obtains an electron configuration of argon. This bromine ion, bromide ion, obtains electron configuration of krypton. So these are the nearest noble gases. All these ions are isoelectronic with the nearest noble gas. So when the charges are equal, you cancel. When they are unequal, you crisscross. Remember, in the final formula, you do not put plus or minus because compounds are electrically neutral. Okay, and these are the ratio of atoms if you have to make those compounds using these elements. Let's do this question. Explain why the following pairs are likely or not likely to form ionic bond. So sodium and helium. If you said no, you are right, because helium, yes, sodium is a metal. However, helium is a noble gas and its octet is already complete. So this does not need to gain or lose electrons. Noble gases don't lose or gain easily. So that is why this pair of elements is not going to form ionic bond. We are talking about ionic, just ionic compound, okay? Potassium is a metal. This one, lithium, is a metal as well. So they cannot form an ionic compound again, because for ionic compound we need a metal and a non-metal. So metals they lose, non-metals to gain. Okay, so this is also no. Here magnesium and iodine, yes, because magnesium is a metal, iodine is a non-metal. So metal is going to lose and non-metal going to gain. So this is yes. Nitrogen is a non-metal and so is the sulfur. So they both are non-metals. So who is giving electrons? Because in ionic compounds, the electrons are transferred from metals to non-metals. So here again it is no, because there is no metal. Okay, thank you students.